Very well. Let's see another example. It's a quick example from angular momentum. So what do we have here? We have a blade that is spinning, and they ask you, what is the angular momentum of your rotating bar? The bar behaves pretty much like a rigid body, and we are making an assumption that the bar is very thin. But first of all, I'm just going to address omega. So the angular velocity given in here in the picture is 120 RPM. Remember that every single time you have to work with it, you cannot leave it like that. You have to convert that in radians per second. So 120 RPM. So that becomes, in order to convert that, you want radians per second. So here's 2 pi over 60. That will convert automatically in radians per second. Why? Because one rotation is 2 pi and 1 minute is 60 seconds. And we can leave this in terms of, so let's kind of simplify it without a calculator. Here you go, 12 divided by 6. So that's a 2 times the other 2. That gives you a 4. So it's going to be a 4 pi. I pretty much like to leave this in terms of pi and simplify everything in the end. All right, so since you are assuming that this is a thin rod, okay, it kind of looks like that, and it rotates about the center, so here's the center of mass, or so how the picture depicts right here. And the moment of inertia for a thin rod rotating about the center is 1/12 the mass times L squared. So we're going to talk about what is it that's going on here. We have the L, which is 2 meters. So out of this, we can find the angular momentum. So this was the moment of inertia. So just remember that angular momentum that was denoted with L, right, is I omega. Now the only thing we have to do is kind of plug in what we know. So 1/12. The mass here, what is it? Is 500 grams, so that's half a kilogram. And then the length is 2 meters, and this will be 2 meters squared, times the omega, that will be 4 pi, and those are radians per second. So if you plug in everything and you use your calculator for that, you get roughly about 2 just by looking at it right now. Let me just simplify a little bit. So here's a 4 times 4, so that's a 16, but I can take this 4, and that will be a 3 times a half. I just want to double check. Yeah, about 2.1. And remember the units for this? So kilograms, meter square per second. All right. Now, do they ask you the direction of it? But they don't, but I would. If you wrap your fingers in the direction of the rod rotation, so right hand rule again, your thumb will point out in the Z direction, right? It's either into the page or out of the page. But think about how you hold your right hand, right? So your thumb will point out. Remember, this is a cross product, so L is a vector. This is only the scalar value, so it's an absolute value. But if you look at it as a vector, then hold your right hand, wrap it around, so the thumb will point out of the page. And just kind of get used to it, because every single time you have to determine a vector that is a cross product between two other vectors, right? Remember L was R times P as a vector. Yeah, which more so becomes I omega. right? So then the direction of the omega is the direction where you're going to put your forefingers or your hand, right hand rule. So that will give you also the direction of L. All right, that's it for this video.